Okay, so this is organized, this trade as you have had by PiLAF. Today, the key one, you should be at the end of the session, you should be able to create and possibly combine data frames in R. Of course, we know what data frames are and how to create them. You will also need to know how to combine them if need be. So one of the beauties of R is that you can work with multiple data frames at the data frames or even data sets at the same time. Today also, you should be able to convert variables that are categorical to factor. Take for instance, age might be entered in label like female, male, or in text or in string like male, female, but R will not be able to understand that. So they need to be converted to factor variables for meaningful analysis. So how do you do that? Hopefully at the end of this training tonight, you should be able to convert. And then 3, you should be able to read data sets in CSV format into R data frame. You learned a bit of this last week, but I hope you will consolidate that experience tonight. And of course, you should be able to check for missing values and know how to deal with them in your data frame. And finally, you should be able to generate sequences. Sometimes you want to draw random samples, maybe from a data set or from data frame. So you will see how you can take a sub sample from your sample. So in terms of coverage, so we will start with data frames, discuss factors, learn how to read data set from a file, and then learn how to handle missing values, and then learn how to generate sequences. You have been exposed to this last week, but this just to simply distinguish the different data structures in R. So vector, we are going to use vector. You use it also last week. You also have these are single type data structures. The vector, the matrix, the array. You can see array is multiple of the matrix. So in matrix, you have the columns and you have the rows. In vector, you simply have a single row and of course multiple columns. So you will have a row vector or a column vector. Here you talk of list, which is more or less multiple types, and you are having separate items. But our interest will be data frame. One thing about vector is that it can only contain data of similar types. So if it's going to be character, it has to be character. If it's going to be integer, if it's going to be numeric, it has to be numeric. But data frame allows you to have multiple data types. So a column, for instance, could be character, another column could be number, another column could be integer. So in data frame, you have the rows representing the cases, and you have the columns representing the variables. We're going to demonstrate all of this. So I just split that as we continue. You can type your questions in the menu chat, in the chat menu, rather. So I will attend to them, and occasionally I will create an interlude to take your questions. So data frame is the most used structure in R, and there is no debate about that. most of you, or most all of us, ultimately will be using data frame because our data will contain multiple data types. So data frame consists of list of equal length vectors. So whether row vectors or column vectors. So, and there is two-dimensional. You have the rows, you have the column. As I said, you can store different data types. So in data frame. So how do we create data frame? This is the R syntax for creating data frame. You can use data.frame, and you will see how that is done. If a data is in matrix, then you want to convert it to data frame. You use this function as data.frame. How is it used? You will also see it shortly. If we have to combine multiple data frames, then we can use cbind. C simply means column bind. R simply means row bind. So we can column bind, we can also row bind. These are R functions that you can use. We are going to demonstrate their usage. Again, with regard to dimensions, in data frame, all columns have to be the same length. In other words, the length in data frame is equal to the number of rows. So anytime you are calling for length, you are actually asking for the number of rows. So you use either the length function or you use the n row number of row function. You can also ask for the number of columns. So we are going to see how that is done. So let's go back to the RStudio and demonstrate that. So before we do that, if you have opened your RStudio, you can now open the script file we want to use today. This is where I stored my own, is on my PC, desktop, and in the folder PiLAF 2022.
Excuse me, sir.
Hello, sir. Hello.
We can't see your RStudio.
Your screen.
It is still at the PowerPoint.
Okay. You are still at the PowerPoint. Can you see it now?
Can see it now.
Yes, sir.
Oh, do I need to go back, rewind?
We can see it now.
Okay, so so if you can see it, then I'm happy. So I'm going to start all over again. So if you want to open file, you can simply see the open file icon here. So click it, and then I'm just fortunate that it takes me to my folder directly. Your own may not take you to your folder just like that. So you need to look for where your folder is. So if I'm going to pretend as if I want to search for my own, since I know it's on desktop, I go to desktop and I look for the folders. Yeah, so I can locate my folder. Some people store their working folder in my document, so you can go if your own is there. There's no problem. For me, I don't normally store. You can see my document. I don't put things in my document. So, so this is my desktop, and this is the folder that keeping doc files, script files, data files, slides, and so on for this training. They are all here. So I double click. This is the script file I'm looking for. So I can open it. Open it now. So it's going to open. So it has opened. That's open. So I believe you should be able to open your own now. Now, is anybody?
Yes, excuse me, sir. Are we using the 1B or 1A first?
1B.
Okay.
R basic 1B. Excellent. That's a good question. So if you have opened, then the first thing we want to learn is how do we create a data frame? So anytime you see the hash like this in R, you are making comments. So anytime you want to make comments, you use hash. R simply it takes it as a non-executable line. So it means it doesn't need to execute the line. And so it's a mere comment. You can put one hash if you want to make comment. And you should form the good habit of making comments. Why? Because if you want to use your script file later, you might not even know what you are trying to do. So those comments helps to remember what you are trying to do. You can also share your script file. If the comments are not there, it might also be difficult for whoever is reading your script file to understand what you are doing. So form the habit of making comments using hash. Now in line 2, I'm creating a data frame. Let's suppose I have to number those people, the first 3 people in this class. I'm giving them serial number. So I can say this is number 1, this is number 2, this is number 3. So X represent the serial number. So I'm using this column vector or the C to collect those values. Now let's say Y in this case represent the age of the people, the first 3. So remember, they must have the same dimension. That's the point we were making. So in data frame, you can have multiple vectors, but it must all be of the same dimension. But one can be character, the other can be number. But in this case, I'm making both X and Y to be numbers. So, but they both have the same dimension. So X here represent the serial number for each of them. So the data frame will create a data frame which will comprise of rows and columns. And then it is stored in DF. Anything that appears, this is the assignment symbol. Anything that appears on the left-hand side is what to define yourself. You can give is a name that you have given yourself. But anything that appears here, they represent R function. So here, this is an R function, and sometimes you can just click it, or you just move your cursor around it, and it will give you details about that function like this. So data frame is the function, and you can see the arguments in that function. So those things inside this suggestion represent arguments. So you don't have to put all the arguments. Some of them are default, so whether you put them or not, it will still run. So whatever result is produced here, whatever data is produced here will be stored in DF. Remember, DF is a name that I gave myself. So you could change your own name to suit. So I call it DF, simply data frame. So I can run this. This is where you come and you click run. So you run. By putting DF here, I could have as well put a function print DF. But I understand if you don't put that, and it's simply saying you want to see the content of this data frame. But before I run this, look at this side, the environment. The moment I run line 2, you can see that it has defined 3 observations and of 3 variables. There is something here which is green arrow. You can click it and it gives you details about the data. Sometimes data, if many, you won't be able to see all of them here. So if you want to see all of them, there's something like a Z here. You can click it. If you click it, up in the environment. Anything about data, you will always see it in the environment. Whereas in history, anything about the command, any command that you execute, whether from the source window or from the console, you will always see it in the history window. So the good thing is that you can save your history for future. But we are not going, those are things we have discussed last week. So let's come back to this source. One thing you will also notice is that anytime you execute a line in the source window, it will automatically come to the console. But if you execute anything, for instance, if I type df in my console and I press enter, yes, it has executed it, giving me the same data that I have here. But the command will not appear here. It will only appear in history. It will only appear in history. So the point I'm making is any command you execute in the source window, it will appear in console. If it is data, it will appear in environment. If it is command, it will appear in history. But the reverse is not the case. In other words, if you execute it from console, it will not appear in the source window. So take note of that. But with time, you'll get to know more about that. So we have created the data frame. That's the point here. Let's create another one because of time. This is another data frame. This time I'm creating X, but I'm still creating the same thing, but in a different way. So this is to say, okay, give me X to be number from 1 to 3. And then create another column comprising of data from 10 to 8. So even though this is 10 to 8, R knows that you are reading the data down. So it's not going to start from 8 to 10. It will just be like this. So let's run this and let's look at the data. So this is it again. So it has, you can see, we have reproduced the same thing, but we have used different command. So then now to the more practical side, let's suppose I now know the names of the students. So I can now use this C collector or the column vector to collect the names. Because names are in character, so I have to put them in quotation, put the quotation mark. So the first person is Dave, the second is Boy, the third is Akim, the fourth is Tolu, and this is their ages. So Dave is 23, Joy is 22, Akim is 26, Tolu is 20. So when you are creating data frame, the critical thing is that, one, there could be different characters, different variables. There could be picture of variables. So character variables, numeric variables, but you cannot have in a vector different data types. It must all be, if they are all characters, they must be characters. If they are all going to be numbers, they must all be numbers. Then two is that you must have the same number of items in each. So even though these are characters, since I'm creating the data frame, I must have the same number because all of them must have the same, they must have equal rows. So let's run number 8, and let's also run number 9, and then we will now use the data frame function to combine the names and the age. This is how we use data frame to combine variables. So we are combining this into a data frame, and we call it DF. So let me run this, and then let me produce this. So you can see, if you want to see, if you run this now, you see it here. So you have the age, the names, and you have the age of the names. So you must not have more values here than here. Otherwise, it will not run. For instance, if maybe out of anxiety, I decide to remove this. I decide to remove this. You know, here now we have 4, and now we have 3. So if I run, let me run 8, and let me run 9 again, and let me say I want to put them in data frame. So it will give error message, and it says argument implied differing number of rows, saying that the first one has 4 rows, the second one has 3 rows. So they are not of the same number, and so you are not able to create that data frame. So I have to return it back. So get that fact well. So let me rerun now. Let me, and then let's reproduce. So there's no problem. Good. So so if you want to know the class and type of the type of data structure that you have created, you use the class function. So if I look at age, for instance, if I want to know what class is that, so I see it tells me it's numeric. It's numeric, and truly it's numeric because you have numbers there. If I want to know the type of data it is, again, it says it's double. So it's double, and then if you want to know the class for names, look at it, it's character, and the type also, of course, is character. For the DF, you should know because DF has already is a data frame. So if I now ask what class is DF, then it runs as it gives you the response. Oh, DF is a data frame. And if I want to know the type of, then it says it's a list. Remember, I earlier told you that these are different data types. So these are multiple types. Anyway, so that is one aspect we need to know about data frame. Let's suppose, as you know, the class, the age that we created, the age that we have. So I can always, if you want to clear your console, you can click Control plus L. So you can just clear the console. Control plus L. Now look at the variable age that we earlier created. This is variable age, and we have seen now that it's numeric. Variable age is numeric, and not only that it's numeric, we have also seen that when we ask for the list here, remember it's numeric, and when we say what type of that, it says it's double. But suppose I now want to force it to be a data frame that vector. I want to force it to be a data frame. Then I will use as.data.frame function. So let me change it to data frame, and then look at it. So it's now a data frame. And if you look at names again, look at names. Names happen to be, when we ask for the class, is a character, and then the type of is also character. But it's also a vector and the data type is for names. The data type is character. You have the characters. So I can force it also to be data frame. So I can run this and then make it data frame. And again, I have this. So in a way, you will see I have 2 data frames now. What type of data is age now? I can use type is list, but look at the data type also is list. So you can use as.data.frame to force a vector to become data frame, a matrix to become data frame. So any data in a particular format or type can be forced to be data frame. So that's when you use as.data.frame function. Just a couple of minutes from now, I will give you time to ask questions. Just few questions. So now, okay, I need to change my color. Okay, good. Now, let's see how we can combine data. Suppose I have data, I have the first data frame. I have data about boys. So I can create a separate data frame for the boys in the class. I have the data frame function. This is the name for the boys. And this is age for the boys. There are 3 boys, Dave, Chris, Ahmed. So if the data type is character, you must put them in quotation mark. If the data type is number, you must put, take for instance, if you come here, you will always see, even I will tell you whether it's character or number, you know. So it will tell you this is number, it will tell you this is character, this is number. Tells you names is character. So this is for boys. Now for girls, I have another data frame. Angel, Absat, Buki. These are the girls, and these are the ages. So I can create a data frame for boys. Then if I want to see the data frame, I type boys in 32. So these are the boys, the name, the age. We have data frame now. So in that data frame, you have columns for variables, and you have rows for cases for the individuals. Let's look at the girls in line 33, and let's look at the data frame. This is the data frame. So here now we have 2 data frames for boys, data frame for girls. I'm sure most of us here, we are researchers, or we are potential researchers. You might be doing cross-country studies. Maybe you have data about Nigeria somewhere, the GDP, the inflation, whatever. And you have that of Ghana, you have them. So maybe for the same time period forever. So there are 2 different data frames. So this thing helps you to combine those data, as you wish. Now, in line 35, we want to use the C bind, which is column bind, to combine the boys and the girls, so that the new class, which will be the combined class, that's why I call it class combined, class C. So whatever is here is a name I've given to the data, the combined data frame. So I'm going to bind. So bind means column bind. Let's run this and see how it column bind it too. Let's see what it has done. So it has put the boys here and put the girls here. So put them side by side. So you have boys here, you have girls here. But this may not really be what you mean or what you want. So in column bind, it puts all the column of the first by the side, the column of the second by the side of the columns of the first. But when we row bind, so these are called class row bind. So I can run this. So I will remember I have that. So that you can see this is what we have when we column bind. And this is possibly what you have in mind, because you want a single variable for name, and you want a single variable for age. So you must be careful how you use row bind and column bind. I want to stop here so that you can quickly ask questions. If there is no question, I'll be very. Oh, I can see Pedro Shamsuddin.
Yes, sir.
You've been raising your hand for long. Sorry.
Yes, sir. Thank you, sir. Thank you for the presentation, sir.
Thank you.
Sir, I have 2 questions. The very first
Okay.
one is that while you are trying to demonstrate how to make use of the data frame, when you created a vector, at the end of the vector, and it is a numeric vector, you used to put double bracket. But if it is a character vector, it is only single bracket that you put at the end. Why? Why do we have that, sir? Take for example,
give me example. Give me example.
The age at the upper part, age, under vector, age. And yes, you can see y is equal to c into bracket.
Can you speak louder?
Okay, you can see y is equal to c into bracket under 2030 when we use it as age.
Okay, you mean here? You mean
yes,
here?
yes. You see the double bracket at the end of that presentation. Why do we have double bracket at the end?
You mean double bracket?
Yes, sir.
Yes. Bracket?
Yes, sir. Yes, sir.
Yeah, this thing is C. This one is a bracket, and you must always close a bracket. Once you open the bracket, you must close it. In fact, if you don't close it, you will see something like red here. So if your brackets are not even, there will be, can you see some red here? It tells you that, so you have to, oh wow. So you need to put it back. I don't know if that addresses your concern.
Yes, I just want to know if there's any reason for that.
Unfortunately, your voice is so low.
Okay,
maybe you can type and then you'll get help. Is anybody typing the question for me? Okay. Oh, somebody said Prof is too fast. Okay. Can you slow down a bit? Okay, I'll try that. Audrey, thanks for sharing. Prof, you made my night. Okay, thank you. I can't see the screen, please. I'm sure you can see now. But if the problem persists, let me know. Okay, I think we are good to make progress. Abel, let me listen to you quickly. Abel, you have the floor. You can unmute yourself. I'm not sure.
All right, Prof. Can you hear me now?
I can hear you.
Yeah, thank you so much for the class. This is my first time, and I think to an extent I could follow through, sir. Thank you for the presentation, sir. So I also want to ask, for the case whether you're having a decimal, let's assume that you are working decimal now. Can that affect the outcome now of these data? So, for instance, let's assume that
don't worry, I can easily demonstrate that. There's no problem with that. There's no problem with that.
Sir.
Yes.
All right, sir. Thank you.
So let me quickly demonstrate that, and we continue. I'm sure your age cannot be, well, we can, most often we just round up our ages. So let's say, Dave, I will change this to Abel. Since you asked question, I will change this to Abel, and then make your age to be 23.45, if you don't mind. So I can run this, and I can run this, and I can create data frame, and I can have the data frame. The only thing now you will notice is the data frame has made your now is numeric. It's numeric. So it doesn't really matter as long as it's number. So it could be integer, it could be with decimal fraction, whatever. So it's not a big thing. So let's make progress. We have our greatest enemy is time, but it's also our friend. So it's the best friend we have. Now I want to talk about. So I've discussed about how you can combine data frames, but how about dimensions? So I'm going to talk about dimensions. But because I generated some of the data we've been using, boys, girls, names, and things like that, I generated them. Let's use one data set that comes with R. You also have the data installed as you install your R, and the name of the data is called CAS. And then you can use data function to read the data, in R. So if you run the data, the moment you run it, you will see the CAS here. This is CAS. Actually, if you click this, you will see more information about the CAS. This is it's about CAS. If you click here, so if you look at it here, there are actually two variables there, and 50 observations. The two of them are numeric. So this is numeric, and then this is speed, which is numeric. This is distance, which is also numeric. So we can use the line 42 to get the first 6 observations. This is the first 6 observations. So if I want the first 10 observations, I can put comma, put 10. And then I type head. So it will give me the first 10. So that's the first 10. If I want something else, if I want the last 6, I can use the tail function. So let me see. So this is the last 6, 45 to 50. If I want the last 8, for instance, I can just put comma and put 8. That will give me the last 8. So last 8 will start from 43 to 50. If I want the length of that, which means I'm asking for number to count number of columns in data set, so I can. So there are. So you have 2. If I want number of columns, I have 2. If I want number of rows in the car, so I have that. This is 50. So in other words, you can always use length, n columns, n rows to get the length, the number of columns, and the number of rows. So that's what I will say so far about data frame. So let's go back to our R and to our slides. So I have talked about data frame, how you can create data frame, how you can use data frame function, how you can use as data frame, how you can combine cbind or row bind, and how you can check whether all columns have the same length and so on. Then the next thing is factors. So when we talk about factors, so just let's discuss 2 slides and then we go back to our RStudio. So factors, they are vectors that can contain only predetermined values, and is used in R to store categorical variables like gender, variable like maybe class of degree, any variable that are discrete, variables that are discrete, or variables that are categorical, color, region, or maybe geopolitical zone. They have predefined values. Marital status, they have predefined values. So many, maybe income, well, you can categorize income also, low income, medium income, high income. So whatever, cars, you can say luxury car, standard car. So you can categorize cars. So factors are vectors that can contain only predetermined values, and we use them only when you know all the possible values the variable can take. So two variables, two components. Any factor must have two components. The first component is the labels, and that represents the values. Take, for instance, marital here is a categorical variable. But these are the labels: unmarried, married, married, unmarried, married. The labels represent the values. So in this class, if I ask the first person, "Are you married?" So yes, I'm married. Yes, so that's a value. I ask this second person, "Are you married?" You say, "Yeah, I'm not yet married." Okay, that's also a value. So each response, if you understand it that way, represent the labels. But the levels, they are the set of allowed values. So in the marital, I can say all I want is whether you are married or not or married. So I only allow two values. So anybody in the class can only belong to any of these. So that represents levels. For instance, gender. So it's either you are a male or you are a female. There are other ones, no problem, but for purpose of our discussion here, we talk of male, female, male, female, male, female. So that represents the levels. But if I'm now asking individual, what's your gender? Okay, I'm a female. That's a value. So that means a label. What's your gender? I'm a male. Okay, that's also a label, and then that's a value. So understand this, and you need to understand them very well before you can go on. So the order of a factor is determined by the order of its levels as specified. Sometimes you are doing some research, and then you want to code. Maybe you want to determine the reference level. So let's say you want to make female to be 0. So you need to know which level you want to set to be 0. So the order of the level of a factor is determined by the order of levels. And I will explain that again. If you don't specify the order, then the order is stored alphabetically, and I will also show you. So let's go now to our RStudio. We have so much to do tonight, and we must achieve. So we are here now. So we want to talk about the factor. So let's look at gender. So we are using factor function. This is factor function. So and I'm collecting the values. So the first person is a male, the second person is a female, the third person is a male, the next person is a male, and the fifth person is a female. So you will notice that in this case, I did not specify the levels, but I have only the labels. I have only the labels. So since I didn't specify the levels, then if I run this, just look at what we have. Let me clean this place. Let me clean this place. So I've cleaned it to make it easy. So let me run this. You can see the gender has been created and is now a factor, and it has 2 levels. But how does it arrange this level? Look at this. When I run line 70, these are the labels, but it has given me the levels in alphabetical order on its own. That's why female is coming before male. But let's go to line 72. In 72, I want to force the first one to be male because I'm a male. So I'm going to specifically state the order of the levels. So I'm putting male first and I'm putting female next. So don't mind my things. All of us will sometimes get biased. So I run that, and when I call, you can see it has come in the order that I specify specify it. So the lesson you must take away here is that one, you can use factor, when you have categorical variables, and those are variables that have categories, predefined categories. And two is that if you don't specify the order of the levels, so you must understand levels and labels. The individual values are the labels, and the categories, the possible categories, they are the levels. So if you don't specify the order of the levels, it will give you in alphabetical order. That's why you have this. And if you specify, it will obey that. So always remember to use levels argument. This is argument for levels. Always remember. So that is the end of that. Is there any quick question on factors? On factors. Is anybody raising up? And this class is a very brilliant class. Everybody seems to be okay. No question for me. Thank you, Tim, for helping me to. Any question? Good. I can make progress. So let's now look at the next thing for today. Yes, let me see.
Yes, sir. I wanted to ask, there's this arrow after gender. How were you able to put that arrow?
Which arrow? This one?
Like line 69. We have gender, then this back arrow before factor.
Line 69. You made this one?
Yes. Yes.
Okay. If you find it, this thing is a combination of two things. So if you press the less than, look for the less than key on your this thing, you will type it first, and then the next one is the
minus.
Is it the minus, or yes, it's the minus dash. But if this is giving you a problem, just put equals to, look for equals to on your so you can always use this in place of this.
Okay, sir. Thank you.
You can always use this in place of this.
Hello, sir.
Hello, yes.
Thank you so much for the teaching, sir.
Yes.
Very understanding, sir. I just wanted to ask that, can one conclude that factors will always be a double option? What I mean by the double option is that it's either true or false, married or unmarried. Do we have a case where the criteria can be like married, divorced, or married, something like that?
Excellent. Why not? So it's possible. For instance, if I want to define, if I want to define, let me see. So marital status, right? So I can say marital. So I have marital, and I have this, and I say factor. So so people must be ready to give me response here. Where are people who ask this question? What's your marital status? Let's keep to three. So
married.
These are the three options: married, not married, then divorce or separated.
Okay.
Is that okay?
Yes, ma'am.
Good. So who is the first respondent? Who is the first respondent?
Married, sir.
Married. So I'm going to use M for married to save time. What's the next respondent?
Single.
Married. Next one. Yes. Married.
Divorce.
If they're not responding, divorce. I use B for divorce. Then let's say the next person. The next person is also divorce. And then the next person is married. The next person
is unmarried.
Unmarried. And then how many so far? 1, 2, 3, 4, 5, 6, 7. Okay, let's get to 10. Unmarried. Yes. Divorce.
Divorced. Married.
Married. Sorry. This should be quotation. So what do you want? Married, and then
They divorced.
yeah. So sorry.
It's 8 now. It's just 8.
It's 8, right?
Yes, sir.
Okay. So I can
Married and divorced.
so married and divorced. Let me what's okay. Okay. I know we are having so it's because of the let me expand this. Good. So let's look at it. You have marital factor. So this is as long as you see any red thing there, it means that there's still an error there. So okay, so let's run this, and then I can now put here marital. Did I press something? Okay, marital. Good. So let's run line 75, and can you see? Because I have 3. So these are the levels. The levels represent the possible
factors.
The possible values that factor can take. So
Okay.
divorce, married, unmarried. But each of these represent the labels. Now, if I decide to include levels and I force the levels to begin with unmarried, followed by divorce, followed by married, then the arrangement will be different. Sorry, there is okay. There is okay. U is not found. Okay, yes. I can you see now? It should be in quotes. It should be in quotes. So great. So let's run, and then you have that. So it has now forced the levels to the desired order. So this is unmarried, followed by divorce, and then followed by married. I hope that addresses your concern.
Yes, sir.
Eh?
Thank you.
It's not there, sir.
Thank you, sir.
It's not there,
You
sir.
have to tell me what is not clear. Is it that everything on the screen is?
I tried to run it, but it's bringing error message. Maybe because I did not include comma or the quotation marks.
It may be. Now, what I will do is that I will copy this straight away to the chat menu, and then you can copy it and run it on your own. Is that clear? So
Yes, sir.
I've copied that command into the chat menu. So you can just copy it and run it. Yes, Abel.
Yeah, Prof. Once again, sir, I want to commend your effort in tonight's class. Sincerely, I'm happy. Now, but basically, I think the last the person that just asked the question now that led us to the issue of a married or married and divorce. She's almost in line with the question I want to ask her. But for people that are for researchers, some of us that we are in pure, let me state it like maybe being in agronomy or soil science that we experiment. Now, I want to ask her. Can you hear me clearly, sir?
I'm hearing you very well.
Good. So I want to ask now the issue of factors now and the treatment, like on our own side, like you are not admitting question here now, whereby this issue of married or married and the likes. No, so I want to ask that can we also can this R of a thing be used in that sense?
Sure. Sure. For instance,
Like,
if you are applying different fertilizers,
yes,
so
you apply
instead of us,
exactly, you apply compost. Hello, sir.
Hello.
Yes,
So
yes, sir.
a variable can be for fertilizer. So instead of marital here, you have fertilizer.
Good,
So
good.
if you now talk about maybe the plot, okay, what fertilizer did you apply? Maybe what are the types?
Maybe you have
AK-47,
compost.
AK-48, and so on like that.
Maybe you have compost, you have NPK 1515, you have
So,
AK-47.
so
in that
the point
case,
I'm making is, so you can have one variable for the plot, one, maybe where you have gender, maybe that's for plot. Then you will have of course, plot will not be a factor. So it will just be a variable name like the way you have names, or the way you have the way I define X, So you can have, so you have plot 1, plot 2, plot 3, plot 4, and then another variable which will be fertilizer will now be NPK, NCK, NKKK, whatever. So there must be the same number of plots as the number of fertilizers. So of course you can have multiple plots receiving the same fertilizer. Yeah, different treatment and so on. So it's possible. It's possible. But we cannot use this example for you because this is general class. There are agriculturists here, there are medical people, there are educationists, there are even Yoruba people here. Can we make progress now?
Yes, sir.
Yes.
Yes, sir, we can make progress.
That question, that Abel is no longer responding. Hello. Okay, I will suspend all questions for now, but just keep your question. We still have a long way to go. We have just about 30 minutes to this thing, and I don't want Dr. Oyelami to punish me. So let's make sure we are. Yes.
Sir.
Yes, quickly.
Is there any place you'll probably...
Don't worry, we will talk about that.
All right.
Okay.
Thank you.
Now, this is the next thing we want to talk about is how to read data. How to read data. Sometimes, I mean, what we have been doing so far is like we are inputting the data ourselves. So that's one way you can get your data straight into R. But suppose you have compiled this data and put in Excel, or you have, so you have compiled this. So how do we now read the data from Excel and then bring it into RStudio? That's what we want to do. So the major, there are different ways of reading data from any format to R or RStudio, but read.table is a function, and these are the arguments. So when you use the function, you have to state the file. That's the file name. You have to state whether the first line should be regarded as the variable, or whether the data is separated by comma or by space, maybe comma delimited, whatever. Then if you want to if you want the character variables to be taken as factors, just what we have just done, you can also use this this argument. If you want a comment in character, if you want also to indicate the number of rows to be read, you can specify. And then if you want to skip certain lines, you can also use the skip argument. So, but this read.table is a special case of read.csv, and I'm going to demonstrate that. So it's a special case of read.table function. You can either use this or you use this one. So let's go back to our RStudio, and the data we want to read is this data that you have. So let me open this is my working folder. So this is the data. The data is read sample sample.csv. Read sample, if you double click, you can see is it's a text. Yes.
Somebody said if you can increase your font size. I don't know whether that is possible.
The font size in the RStudio is big enough. I think you can see the font size in the RStudio. It's usually when I'm not in. Am I correct?
Okay, yes.
Do you still want me to increase the one in RStudio?
No, it's fine, sir.
I think this is
Except that using a phone.
So, but let me just for for academic this thing. Let's suppose that most of you, I'm not sure you know how to use. It will take our time. Let me not go that far. So, but for now, what we want to do is that file that is in this file, read sample.csv, is the data we want to read. And we want to read this data and bring it into RStudio. How do we do it?
Yes. I have mine in Excel, not in Notepad.
Not in, well, it's because I can also open this in Excel. No problem about that.
Sir.
So
okay, sir.
if look at it now, I can come here and open it as Excel. And it's good you have even mentioned this. Is that okay?
Yes, sir.
Yes, sir.
So maybe something is so I'm going to open it in Excel so that we can see the data. Most often our data we come in Excel format. So this is the data in Excel. Actually, it's like this because the data is saved as a CSV. Most of us don't know how to save data in different formats. Let's say I'm saving this now, for instance. Let me not even save it as, so, you know, I have clicked save. Let me save as. So this is the format, but I want to save it. You can always come here to choose whatever format you want to save your data. So if I save it, for instance, as Excel workbook, I can save it this way. So let me just call this one. So it's now saved as read sample 1. So it's saving as read sample 1. So what you should always do is that anytime you have your data in Excel, then you can save it in 2 ways or in several formats. Those are, you have seen the different formats that we can use. So, but I'm only going to teach you one format tonight because of time, and that is the CSV format. The data is originally saved as the CSV format, that is comma separated values format. It's taking time, so let's go back here. So the first thing you have to do is to know the current directory you are working from, and you will use the function get WD. So if I run this, it's telling me that my current directory is in C, users, progressive, documents. So that's not where I want to go. So now that I know my current position is not where I want to go, I have to now go to session and then set my working directory, go to choose directory, and then help RStudio to locate where my directory is. And this is the folder, and then I open. So this is my working directory. And so you can just copy this and paste it in line 83 to replace my own that is there. So replace my own with your own, because if you run this 83, you will get an error message. So let me repeat the process. You go to session, go to set working directory, choose directory, and then the choose working directory window will open. Then you look for where your working folder is. It's on the desktop, and then look for the folder. Click it, don't double click it, and then click open. And then this thing will come. So you can copy and replace line 83. That way you have set the working directory. You have set the working directory. As a matter of fact, if you come here to your files, you will see all your files, all the files that you have. In fact, look at the one I created, read sample 1.xls. You see it here. So once you come here, so it means you are now in the right directory. And the data you want to read at this moment is this data, read sample.csv. That is the comma separated value. So you can use the read.table function. So if I read it, then it will save it as data frame df. So so it has read. In fact, you see this is the data now. It has 12 observations and 5 variables. That's 12 observations, 5 variables. And what are the variables? V1, V2, V3, V4, V5. So this is a character. Of course, there's a problem here, as you will see. You will see that it has, when you use read.table function, so let me show you what it has read. So this is V1, V2, V3, V4. And that's not what to actually mean, because this number 1 should actually be the variable name. So, so it has read it, but it has not recognized the first row as the variable name. So you will now go back to your script. So if you print this, what you have seen there is what you see here also. So it doesn't recognize number 1 as a variable name. So, but you want that to be the variable name, and you will see instead of you having 11, you have 12 instead of 11. So you can ask, what is the class? It's data frame. There is no problem with that. But the problem now is that you need to use the argument header and set it to be true. In other words, you are telling it the first line that is there, you should take it to be the header line. So that is the variable. So if I run this now, and then I print df, the story has changed. So the first row is now taken to be the variable name. And so you can see we have only 11. So you have the first column to be name, followed by age, residence, whether active or not, and result. If, for instance, your data is not comma, you will notice that in our when we open the data, it's not comma separated actually, because if it's comma separated, you will see comma separating each value. So what separates one value from the other is space. So space after Alice, space after 25, space after Lagos. So if it is space, then you can add another argument, separator argument, and then just put double quote. It's saying that it's separated by space, and you can run this. Of course, it's truly separated by space, so there's no problem with that. But if it's separated by comma, then you will now need to put comma here to show that it's separated by comma. So you need to study, look at your data, in what format is it saved, and how are the values separated. So you can run this. I think we have done that. And then whenever you type str, you are asking for the internal structure of the data. You are asking, how is the data, what's the internal structure? So it tells you there are 11 observations, 5 variables, and the first one is name and its character. The second one is age, is integer. The third one is residence and its character, Lagos, 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 Accra. The next one is active and its logic, whether true or false. In other words, it's about whether this person is still in active service or has retired. This is results, is either good or bad or fantastic. So it's character. So that's all about using the read the table. There are other arguments you could use. So, but our data actually is in CSV format. Our data is in CSV format. So we can as well use the read.csv function. This one is easier. Also, our data is saved in CSV format. So it's always good for you when you want to save your data to go to this and then save as, then come to save as type and look for where you have comma separated values. This is CSV. This is CSV. You will see the CSV for MS-DOS. That's the one you should choose. There is also the CSV UTF. That's the one you see in the notepad. So whether you choose this one, this CSV, or you choose this one, CSV, your computer is not Macintosh, so I think your own should be MS-DOS. So you choose this, they give you the same. So you save in that format. If you save in that format, then in your RStudio, you can always come and use the read.csv function. And then you simply state the name of the variable here. The name of the data file here. And then you read. So easily, so this is the data. Unfortunately, it has read it, only that it's reading it as if it's a single column. As if it's a single column. In fact, it's reading it as a single variable. All that you now need to do in this case is, because it's not comma separated, this thing means comma separated, but our data is actually space separated. So you use the separator here, and then you run, and then you get what you want. So this is how to read data. This is how to read data from a CSV or from even Excel data. Now, two more things, and this time is running so fast. We're almost there. This time is running so fast. So quickly, how do we handle missing values? Missing values, generally, you could have NA, which means not available, NaN, which means not a number. So the quick thing you can do is check for missing values, and this, you use this function is.na, which means, is there not available observations in your data set? So it will quickly check and tell you whether whether true or false. Is.nan is that anyone that is not a number? No. Maybe if number has been mixed with character. So two ways of checking for missing values is to use the is.na function, is.nan function. And dealing with it, you can use, you can say use complete dot cases or na.omit. So how do we use them? Let's quickly go back to our RStudio. Some people said I'm too fast. Please don't be annoyed. You might just need to carefully find time to watch the video over again. I believe if you watch it and you watch it carefully, you also with your participation, you will get it easily. So to demonstrate issue of missing values, I'm going to use data that is inbuilt in R. that comes with R, and the name of the data is air quality. So let's run this to get the data. Before, let me clear everything here, and then let me run it again. So this is the data, air quality. So it's a data that has 153 observations, 3 variables, 6 variables. And the data has variable on ozone, zola.r, wind, temperature, month, day. So that's the data.
Where
6
do you get the
variables.
data from, sir?
It's in the, it comes with R. So once you run line 106,
Okay,
you
sir.
use data function, it will automatically load.
Okay, sir.
Yes. So it's in R. So just run 106, it will load. Now, I've told you if you want to know how many number of rows in that data, just type n rows and then the name of the data, and then you can get that. So there are 153 rows. What is the internal structure of the data? Then use the str function, and then you can easily know. So this is the internal structure, 153 observations, 6 variables. Ozone is the first variable, solar.r is the second, wind is the third. So ozone and this, they are integer. And you can see some of them have NAs. That's even why we are using ozone, there are NAs there. So at that particular point in time, no data or no data is not available. So then we can now ask questions in 106. Because we want to check whether there is NA. So we use is.na and then the name of the data frame, air quality. So so this is what it does. So it will tell you, take every case. So this no NA first, no NA, no NA, no NA. But where there is NA, it will say true, true, true. So you will see that. And there are 153 of them. So, and you can see NA is common in ozone, in the first variable zone. NA is common. No data in this period, no data here, no data here. It's NA. So normally in some analysis, you may not be able to work. For instance, if it's regression. So once there is NA in any row, so that row will be omitted. So in line 10, we are using the complete dot cases. So, and when you use this, let's run that.
Oh, sir.
So, yes.
I would like to ask, in the data structure that we're having this missing observation, I think in the last class there was a line Mr. Tim wrote for us to check, like now the data is much and we have many false and true. Is there anything we can just write just to know, okay, we know true is 1 and false is 0. I can just instruct and say, okay, if it tells me true is 5, then we can know that, okay, we have 5 missing observation, or we have I don't know if you get my question.
I understand, but the situation here is that we are dealing with data frame. So when we are dealing with data frame, it's going to give you information on row by row cases. That's why you have here. So, but what you are saying, I will still address it. Don't worry, we'll get there. Just a little patient. So, but first of all, you should know how to check whether you have. I know it's quite massive, to start checking this. So, but it's also at times necessary. So quickly you can see cases where that is those rows where you have NA, and then when you use complete dot cases, so it's only going to look at cases where data is complete. So you can see for 1 is saying is complete, 2 is complete, 3 is complete, case 4 is complete, but case 5 not complete, case 6 not complete. So up to 9 here, this is 10, 11, and so on. So you can, but sometimes all you just need is to say, okay, I only need complete cases, and I think that is the thing that is of interest to you. So you use the na.omit. In other words, all cases that are not complete should be omitted in the air quality data set. And then there will be a new data set, which is here. So if you run this now, all those places where you have false, it will omit them. It will remove them. So of course, remember the total cases is 153. So when we run this now, and then let's look at the data. So it has omitted those cases. It has omitted all those cases. That's why you have 1, 2, 3, 4, but 5 has been omitted, 6 has been omitted, then you have 7, 8, 9, 10 has been omitted because that case is not complete, and so on like that. And to know how many are left, you are left with 111 cases out of 153. So those rows that are not rows with not available has been removed. So this is how to now use these complete cases for further analysis. So instead of using air quality with data set with cases of NA, you are now going to, with the use of NA omit, you are going to have air, which is now complete cases. So this is how to deal with NA. So 2 things you must know, there are rather 3 things. What NA means, not available. What NaN means, not a number. And how do you check? Do we have NA? Do we have is dot not a number? Then how do we deal with it? You can check for complete cases, or you can omit NA cases. Good. This is the last thing for today. Generation of sequences. So we use SEQ function. You can generate number of any from starting from any value to any value, and then you can use by to indicate the increment. So I can generate a number from 1 to 100, and that will be from 1 to 100. And I say, okay, I want it to increase maybe by 1, by 2, by 3, by 4, and so on. And then I can also put the argument, the length out to decide what to be the desired length of the sequence. I can also say, okay, I want the length to be similar to the length of another variable. So how do we do that? Apart from the SEQ function, there is also the replication function, there is the paste function, there is the sample function. Let's quickly look at that. For instance, without even using any sequence, I can simply create a serial number from 1 to 100. Let me run line 116. So if I want to see, so I just generated the number from 1 to 100. The same thing that I have done here, I can also do it, creating my sequence using the sequence function, and then saying I want a number from 1 to 100. This is the starting point. This is the end number. And I want it to increase by 1. So increment by 1. So it's going to give me the first to be 1, followed by 2. So if I run this, I'm still going to get the same thing. And I can now see it here. Excellent. So I have this. Now suppose again that I want the increment by 2. So I'm not going to have as many as I have here. So let me run. This time again. So I only have 50. So the first one is 1, followed by 1 plus 2, 3, 2 plus 3, 5, 5 plus 2, 7, and so on. Suppose I want the increment by 10. Then I have this. So I can only have this. The first is 1, followed by 11, followed by 20. So because it's increasing by 10. Again, if I want the sequence and I want the number from 1 to 100, but I don't even want to state what should be the length. Sorry, what should be the increment, but I only want 4. Give me any 4, make the sequence such that I should only have 4 values in that sequence. So I can run this. So it's saying this is number 1, this is 34, this is 67, this is 100. You can see that the increment is constant. The increment is constant, adding 33, 33, 33. So if you know the desired length, you can just use the length out. How do we apply this, for instance? Sorry, we will finish in a couple. Oh, wow. Okay, in a couple of minutes, we'll finish. How do we apply this? Suppose, again, this is gender, and I have male, I have female, I have male, I have female, I have female. Now, I can run this. Excellent. Then I can create a sequence such that is of the same length with this gender. This gender has 1, 2, 3, 4, 5, and I want to create another sequence of this length, 5. So I will use along with gender. So I will run this, and then there will be only 5. So which means this will be for the first male, this will be for the female, this will be for the male, and so on like that. So how do we use rep? That's when you want to replicate. So for instance, I have female, I have also, this is the number of times I want female to be replicated. So I can run this, So they are replicated female 5 times. Let's say I have female, male, and I want to replicate them 3 times. So I have this female, male, female, male, female, male. Again, let's say I have this age of first person, age of another, age of another, age of another, and I want to replicate them 4 times. So I will say, replicate 4 times. So I have that. So the number will be replicated 4 times. If I have to replicate, this is say 1 to 5, and I want to replicate it 4 times. That's that. So 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5, 2, 1, 2, 3, 4, 5, 3, 1, 2, 3, 4, 5, 4. Here I'm saying I want each of them to be replicated twice. So 1 will be replicated 2 times, 2 replicated 2 times, 3 replicated. So that's it. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Here I want each replicated twice, and then I want it repeated 3 times. So that is it. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. That's 1 time. 1, 1, 2, 2. That's the second time, and so on like that. Finally, we are almost. This is the last thing we are doing, and I want us to listen. So in line 145, we have names. Let's say you have your data frame. So we have name of the students. We have the names, and also, of course, we have the gender, but this time I have the gender in factors, and I've defined the levels of the factors to be male and female. So which means the male is the first. So I can have, so you recall the discussion about the order, since the levels have been specified. Let's have the marital or married, and then let's have this. This is also the level. So I can create a data frame for all of these names, gender, marital, so that all of them will be together. And this is the class. So there are 5 in this class. I can use the sample function, for instance. I can use the sample function to select among this. I need only 3. I don't want all the 5. I want to randomly select only 3 members of this 5-member class. So I can use sampling without replacement. So let's do that. And then what are the samples? So it has selected number 4, selected number 1, selected number 3. So I can now use this to, okay, those that were selected, let's know them. So these are those that are selected. So it has selected number 4. Number 4, let me move up a bit. So number 4 is Tolu. That's why Tolu is here. Number 1 is Dave. That's why Dave is there. Number 3 is Hakim. That's why Hakim is there. Suppose I don't bother if the sample is replaced, so I can talk of sampling with replacement. So I'm also still selecting 3, but replacement is allowed. So replace is true. So I can run this and I can run this. So it's only selected 5, 4, 5. Since replacement is allowed, then let's look at those that have been selected. So Bola selected, then Bola again selected. So Bola, Tolu, Bola. Thank you. This is where we are going to stop tonight. Sorry, I've taken a little extra time. Why not?
If I want to replicate, like in line 145, you said we can replicate each twice. But suppose I want to replicate one once and the others twice. Is it also possible to do that?
Anything is possible. It's just to understand the logic and then the rule.
Okay.
So you can just try. Sometimes you try and you fail, but eventually you get it. Because we have already overspent, we are on the borrowed time now. I don't want to over. Yeah.
Okay, sir.
Yeah, Missy.
So my question is, sir, if you had already, like earlier when we're doing Marita, we used to code for the levels, and then later here I still see that we were able to use Marita or married. I wanted to ask if what we had done earlier can affect what we are doing now. What I mean is, if maybe we have said Marita is UDM and now we are changing it to unmarried married, is there going to be any difference, sir?
So normally what happens is that if you have assigned a name to a variable before and you reassign the same name to another thing now, this one will override the previous one.
Thank you very much, sir.
So that's why you should always be careful, so that if you don't want the previous one to be written over, you have to give a new name to separate the old from the new one.
Thank you very much, sir.
Thank you. I think I can hand over to Dr. Yelami now.
Thank you very much.